In this lesson, we have dilation 6.05. Dilation is a type of transformation that changes the size of the figure without changing the shape. Dilations can make a figure smaller or larger. So depending on the examples you see below, either it's making it larger, as in the left case, and smaller, as in the case on the right. Now, when you make an object larger, you have an original figure that we refer to as the pre-image, and you have a dilated figure that we refer to as the image. They're dilating around or about the fixed point, which is known as the center of dilation. Now, the scale factor, and this slide is actually very important for your exit ticket assignment, your exit tickets, right? It talks about, of course, how when we dilate a figure, do so by making it larger or smaller, and the ratio of corresponding sides is the scale factor. Ratio of corresponding sides is that scale factor. So we've been discussing that concept since we've been talking about similarity. If you have similar figures, that ratio of corresponding sides is the scale factor. And there's three instances to think about. Number one, if your scale factor is between 0 and 1, it will be a reduction. If your scale factor is greater than 1, it will be an enlargement, meaning it gets bigger as opposed to getting smaller, right? So again, a reduction is getting smaller, an enlargement makes it larger, and then lastly, we can see that if the scale factor is negative, the image flips. Now, more specifically, that refers to a 180-degree rotation about the center of dilation. But it looks like it's flipping. Now, I want you to pay attention to that, right? If you see that occur, if you see that happen, please pay attention to the fact that you will have a negative scale factor. That can help, especially if you're doing process of elimination and you want to select an option that also has to be negative, because maybe you notice that this 180-degree rotation is actually occurring in your problem set. So let's take a look at an example. Here I want to identify the coordinates of my pre-image, and the coordinates of my pre-image are QRS. Q is located at -2, 2. R is located at 2, 2, and S is located at -2, 1. Then, of course, we have the image, right? Now, this is the image. One way that I know that, of course, is the prime notation. That tells us it has to be the image. And this is the pre-image, right? The original figure. Now, remember what scale factor can often be described as, right? So when we talk about scale factor, I'm going to call that SF. It's all about what's new over what's old. So in our case, we want to identify the scale factor here as an example, because in order to find the coordinates of our image, assuming that the image isn't provided on the graph already, which here it is, but if it's not, we can identify the scale factor by taking corresponding sides like Q prime, S prime, for example, and QS. So in our case, the new would be Q prime, S prime, and the old would be QS. Now, we can very clearly see that with vertical lines, you can count the distance very easily. In that case, you see over there on the left, with Q prime, S prime, we have 5, right? So the length of Q prime, S prime is 5, and the length of QS is just a little old 1. So that tells me the scale factor is going to be 5. I want the scale factor because I can use it to identify my new coordinates of Q prime, R prime, S prime. How do we do that? Well, we're going to take the scale factor of 5 and we're going to multiply the X and Y values of every ordered pair in our pre-image. And by doing so, we can produce the coordinates of our image. So for example, here I would get -10, 10, which you can confirm over there on the left. You get +10, 10, and you get -10, 5. And all I had to do was multiply the original 3 ordered pairs and their x coordinates and y coordinates by the scale factor to result in the correct ordered pairs for my image. Let's try that one more time. Here is a rectangle. We are tasked with identifying the ordered pairs of the image, which is not graphed, by being given the pre-image coordinates that are provided above. We have a scale factor of 1/4. Now, 1/4 is our scale factor. That means that with a scale factor of 1/4, being that it is less than 1, is a reduction. So of course, this is going to make our figure smaller. Now, a little thing that you should keep in mind, you're multiplying every single one of the x and y values by 1/4. What that looks like then is the following. You'll take -8 and -4 and divide them both by 4. Because when you multiply by 1/4, you are dividing by 4. If you take 1/4 and multiply -8 by 1/4, you get -8 over 4. So multiplying by a fourth is the same as dividing by 4. And I'm going to take each and every one of my coordinates for my pre-image, and I'm going to divide every single one of these by 4. And I just need to simplify those to come up with my coordinates for my image. And so here I get -2, -1, +1, -1, +1, +2, -2, +2, and those are the coordinates of my image now. And I can even go to the graph and plot that. I have -2, -1, 1, -1, 1, 2, and -2, 2. So you can see it's much smaller than it was before. Please pay attention as well that the center of dilation is actually the origin. Excuse me. Let's try that again. So here is another figure on the graph. It's the triangle JKL, and we want to identify first the coordinates of JKL. So we have J is at 2, 4, K is at 1, 1, and L is at 4, 0. And the scale factor we're going to use is going to be 2, where the center of dilation is located at the origin, 0, 0. So here we're going to multiply both the x and the y by 2. And that is true for every pre-image coordinate. This will result in the new coordinates of our image. So for example, here I get 4, 8, which is located right here. That'll be our J prime. Here I get 2, 2. So that's going to be located here. That's our K prime. And then here I get 8, 0, and that is going to be my L prime. And now I can go ahead and construct or connect the vertices of this triangle, which is the image of the pre-image. And they're similar triangles. They have the same shape, they have different sizes, they're similar triangles. The scale factor between them is 2. The ratio of the corresponding sides is going to be 2. And that is an example of that. So just as an illustration to remind you of this, because it could be important as well and can be helpful, keep in mind that in these two examples, I already know instantly that the scale factor for both of these will be positive, not negative. How do I know that? Well, one way that I know that right away is if I look at, for example, how to find the center of dilation, the way we do that is we connect a pre-image and an image coordinate. And you can see I've done that. Now that's not enough to find it. You have to have at least 2 of those lines. So for example, if I were to connect E prime and E, I would also be able to do so. And it goes to the center of dilation all the same. And I could do that for F and F prime as well. Now when I go ahead and I do that, please notice something. And I'm going to highlight this with my little blue marker here. Notice how both the pre-image and image coordinates lie on the same side of the center of dilation. These two are above it, these two are kind of to the left of it, these two are both below it. That's how I know it's a positive scale factor. There's no flipping, there's no rotation that's happening there, right? Same thing over here as well. If I connect these, you actually only need to connect at least 2 pairs in order to know the location. You don't have to connect all 3, but if you wanted to connect all 3, you almost certainly could do so. And as you can see, once again, these 2 are both above, these are over here, both in the same position. The center of dilation is down there, they're over here. These 2 are over here, the center of dilation is over there. that means that also is going to be a positive center of, or a scale factor. Okay, so those are just how we find the center of dilation, and ultimately we can tell whether the scale factor is positive or negative by doing that and by identifying that feature. Now, what I want you to do here is I want us to find the scale factor, right? So my tip to you is to think about what I did earlier. I went ahead and I kind of looked at a vertical line pair. What you really want to do is focus on horizontal or vertical lines. Why? Because they're the easiest to count. They're the easiest to determine the length of. For example, I can see here that if I look at A prime, B prime, I'm going to get 12. If I look at AB, I'm going to get 6. I can count that. And remember how we find scale factor, right? We do new over old. New over old. So we have A prime, B prime, which is new, over the old, which is AB. So that's 12 over 6, which equals 2. So I know that the scale factor of this figure has to be 2. Also, by the way, pay attention to something else. That actually tells you how to compare your corresponding sides, right? So when it says from ABC to A prime, B prime, C prime, technically speaking, we're actually supposed to go from ABC to A prime, B prime, C prime. So whatever we have for the new, that's going to be over here, and the old is going to be over here. That's how I know what goes over what. New always goes over old. Here we get 2. It's gotten bigger. It's gotten larger. But that's not the same thing that happens here. If you look at this one, it says from DEF to ABC. Remember, this is the new, and this is the old. So what we need to do is figure out a length, in this particular case, that is either vertical or horizontal, preferably, if we can do so. We don't have to do that. We can use the distance formula as well. So just a reminder, the distance formula can be used on problems like this. You certainly can, because you do have 2 sets of ordered pairs, and therefore you could use the distance formula to find the length. However, I'm noticing that we have some horizontal lengths, for example. We have EF and we have BC. And remember, I want this to be my new length. I want this to be my old length, right? Because it says from DEF to ABC. So if it says from DEF to ABC, it's getting smaller over time, not larger. Okay, not larger. It's actually getting smaller. So if you count that distance, BC, one way that you can do that when it's just a horizontal line, you can count it, of course, which is just 2. However, you can also show that by taking the difference of the x values. By taking the difference of the x values, I get the absolute value of -2, which is +2. Again, you could also count that. And likewise, you can do the same for EF, right? We have absolute value of 2 minus 6, which is the absolute value of -4, which is equal to +4. And remember, we want new over old, right? So new over old. Well, the new is BC, the old is EF. So in this case, we have 2. We're going to divide that by 4, and that gets us 1 over 2. So here, it makes sense. It's getting smaller, right? So the scale factor is going to be +1/2. By the way, do you notice how the figures are on the same side of the center of dilation and our scale factor is positive? That makes perfect sense. They should be on the same side of the center of dilation if it's gotten smaller. And in this particular case, that's how it's outlining that. That's how it's illustrating that. So that is going to be our scale factor in this instance here. So pay attention again to this order here, because that can tell you what's old and what's new. It's always in that order, right? Old, new. And that tells you what you put over what, right? So the segment that goes with triangle ABC was this one, and it goes over the segment that belonged to triangle DEF. And that's how I know for certain what the scale factor needs to be here. So your exit ticket, you have to find the scale factor for all 3 of these. On the first question, you're not going to find the center of dilation. You don't need to worry about that. Just remember, the key feature here is taking our new length and dividing it by our old length, okay? And of course, keep in mind you have to know what the new and the old is, right? So pay attention to things that involve prime notation, for example. That should outline right away what's going to be the new length divided by a corresponding old length. Pay attention to whether you have to deal with positive or negative scale factors. What can give away or help reduce your options when selecting your scale factor in the question, in the second question as an example? If you look at the last question, as well. Also pay attention to that concept of how do you find that center of dilation. How, if you're looking at the figure in the dilation, what's going to be considered old, what's going to be considered new. Okay, if it's forming CD, that should tell you what's going to be new versus what's going to be old. And then you can compare those lengths and also just deduce which particular value you're supposed to come up with. If something's getting larger, we know there's a specific rule that you have to follow, and we know a specific range of values for scale factor when it is getting larger as opposed to when it's getting smaller. Okay, and that's going to be our lesson 6.05 over dilation as it relates to similarity and scale factor.